Hello all, this 8051 video tutorial is on getting started with KEIL, PROGISP and C programming. We'll be using this type of demo board, and the IC used is 89S52. The family name is 8051, but the IC used is 89S52, which is 8K flash, and it has got 4 ports, P0, P1, P2 and P3. All are 8 bits, as this is a 8-bit microcontroller. And at pin 18 and 19 we can use a crystal 11.059 megahertz crystal, and pin 40 is VCC, pin 20 is ground. Power used is 5 volt. And for serial communication we have RXT and TXT at P3.0 and 3.1, pin 10 and 11. And for SPI flash programming, the pins are MOSI, MISO and SCK. RST pin is at pin 9, which is high to reset. When you give high, it will reset. And also interrupt pins are there, P 3.2 and 3.3. Now let us see the hardware. The IC used is 89S52, and the demo board, project board, has got a zip socket. You can place the IC 89S52 on the zip socket and lock it. And the programmer used is AVR Dude. This is also called USB ASP. The IC used on AVR Dude is 80 Mega 8, and the same board is used for programming AVR ICs also. This is in-system programmer, and the MOSI, MISO, SCK pins are used for programming. Let us connect the USB cable, A to B cable, to PC, and ISP pins to the project board. The ISP pins are SCK, MISO master in slave out, and MOSI master out slave in. The ground pin connection should match the board and as well as the programmer. This is very important. Now in the project board, the IC to be placed in the correct direction. The IC has got a dot at the pin 1. There is a dot near pin 1, and this dot should match the handle of the zip socket. This zero insertion force socket. You can place the IC on the socket and just lock it. The pin 1 should match the handle. This is very important. If you reverse the IC will fail. So place the IC on the zip socket and lock it. And the port pins are given with Berg pins. That is, to the right is P0, to the left is port 1, and to the right bottom is port 2, and left is port 3. All port pins are extended using Berg pins, and you can see at port 0 pull-up resistor array is used. So for port 0, pull-up resistors are very important, and crystal is 11.059, that is connected across 18 and 19. The ISP connectors are provided at the top. This is the SPI connections to where the AVR Dude programmer is connected. While using ISP, no separate power source is required. Otherwise, a 12 volt 1 amps adapter is required at this power socket. While using the adapter, on board there is a power regulator. A bridge is there, and 7805 IC, which provides 5 volt supply to IC. While using ISP, the ISP programmer itself will provide the 5 volt supply, and there are 8 LEDs for testing purpose, and LED inputs are provided as Berg pins. For LEDs, there is a common resistor to ground to control the current limit, and 12 volt pins are provided at the center, and then ground pins and 5 volt pins. All pins are extended that can be easily used while connecting sensors, and 4 push buttons are there at the center. This is for testing key inputs, and there is a reset pin. When you press this pin, high is applied to pin 9, which will hard reset the IC. And to the left there is four 7-segment LEDs. This is common cathode displays, and it is the selection is driven by BC547 NPN transistors for selecting 7-segment, and then 7-segment pins A, B, C, D, E, F, G. All are extended using Berg pins. To the bottom of the main IC is the MAX232 IC, which provides the serial conversion from TTL to RS232 level. But programming is through ISP and not through this serial port. You cannot program through this serial port, as this IC does not have any bootloader. And to the right, there are two small 8-pin ICs. First is the DS1307, that is the RTC IC, and the second one is the E-square PROM, electrically erasable E-square PROM IC, 8-pin ICs. RTC is for clock operations. And to the right is the ULN 2003, which can be used as a motor driver. And for ADC, there is ADC 0804, which is single channel 8-bit IC. And for demo, one preset is also provided for testing analog inputs. And there is a 4x4 dot matrix keypad, and the pins are extended using Berg pins. To the right is the LCD connector. This LCD can be plugged into the end connector. There are two rows. The end row is for connecting the LCD, and the inner row is for connecting the port pins. The LCD pin configuration is printed on the board. The LCD is connected with the female Berg connector, so it can be easily plugged onto the baseboard. To the right is the pin 1, to the left is the pin 14. You can press the LCD fitting like this, LCD to face outside, and there is a preset to control the contrast of the LCD. Now let us connect the AVR dude, that is a USB ASP, to the baseboard. The USB ASP has got 6 pins. This is SPI communication pins for programming. You have to connect it to the ISP pin of the development board. Take care to match the ground pin, that is the ground of USB ASP, to match with that of the development board. The power source, no separate power source is required for the development board. The power will be taken from USB ASP. Now open the device manager. You can see USB ASP with the exclamation mark. As we have not installed the driver yet, it will show exclamation mark. The driver download link is given in the description below. You download it, and you can see install driver.exe file. Double click on that to install the driver for USB ASP, and follow the instructions to install the libUSB driver for USB ASP. Now if you go to device manager, you can see the exclamation mark has gone, and it is under USB ASP. That is, it will not show under ports, it will be a separate display. Now let us install the KEIL software. This is the integrated development environment. We are going to develop the hex code for this 89S52. Download the C51 software. You have to provide your email ID to download this software from the KEIL website. Download the ARM KEIL software and then install it. Next is the PROGISP software for uploading hex file onto the 89S52 IC. No installation is required for this PROGISP. It is just a standalone software. Just copy the folder to your desktop and then open it. Now install the downloaded Microvision KEIL software and open the software. This is the welcome window. It has got 3 windows. Left side is the project window, and the bottom is the output window. To the right is the editor window where you write your C code. To start with, you have to create a folder for your project. You create a folder anywhere on your desktop or on your drive and provide a name to the folder. Let us give a name LED_blink. Under this folder we will store all our project files. Now go to the KEIL software, click on project, a new Microvision project and then provide a project name. Now let us provide a name as LED_1 and click on save. You have to select the folder we have created for your project files, that is the LED blink folder. Now the next window, you have to select the device. Select the device as AT89S52. You have to select the correct device, otherwise hex file will be a defect. Click on OK and confirm this startup.a51. This is very important. You click on yes for this. Now your project is created under the project window. Under this project window, target 1 is there and source for the group. Right click on this inside the project folder. You can see the project has been created with 2 folders, listing and objects. Now nothing is inside as we have not created the hex file. Now right click on target 1 and go to settings for the target, that is the options for target. You have different tabs. Select on the third tab, output tab, and put a tick mark for creating hex file. This is very important, otherwise your hex file will not be created. That is under the output tab, and there are many tabs. And under debug tab, ensure that use simulator has got a tick mark. This is for using the simulator. And most important is the output tab, where you have to put a tick mark against the create hex file. Click on OK. Now right click on the source group and then select add new item to group. If you click on this add new item, you will be taken to the next window where you have to select the C file, as we are going to create C file, and provide a name for this file. .c extension will be automatically provided. Just provide a name and then click OK. Now this .c file has been added to the project, and on the editor window you can write your code, C code. Inside your project folder you can see the .c file along with the listings and objects folder. Now let us see the C code inside the editor window. To start with, you have to include the header file. Include reg52.h, which is the 89S52 header file, which defines all the port pins, port definitions and registers. If you provide this header file, then the compiler will understand your port notations P0, P1, P2 and other registers. So this header file is very important. It has to be included in the top of the code. Next is the main function, void function. This is the main function, and inside this there is a never ending loop. For never ending loop we use the while function. This starting and closing braces you have to provide manually. This will not be automatic in KEIL. So while one is the never ending loop, and for that also braces you have to provide. This code which will be done repeatedly. You can also use for and 2 semicolons for the never ending loop, but generally while one is used. So main function is inside the main function there is a never ending loop, and here we write the code which will be repeated. P0, that is a port 0, we will make it as 0x. 0x notation for hex, and FF means all pins are high, that is 11 11 11. All pins will be high initially, and the P0 is made 0x00. That is initially it is on, and then it is made off. Between that we have to provide a delay. So delay function is not defined in KEIL compiler. We have to provide manually. Let's provide the name as delay_ms and pass on a parameter 1000. That is, we want 1000 millisecond delay. Let us write the delay function now. to the top we have to write below the include statement, that is void delay underscore ms, and we use the data type unsigned integer, unsigned int, and then we provide a name time. Any name you can provide, but the data type we use is unsigned int, which is 2 bytes, that is 16 bits from 0 to 65535. If you are using a char data type, then it will be 0 to 255 only. So we are using unsigned int data type, and then we write the code for the delay. We use again two unsigned int variables, I and j, and then we use a for loop. The first for loop is for the first data variable, that I, and inside that for loop another for loop is created. This is called the nested for loop. Second for loop is for the second variable j, and we use j for and a value less than 1275. This will create a delay of 1 millisecond approximately. This is called a nested loop, and note the usage of semicolon only for the second for loop. The first for loop there is no semicolon. That means the next line, the next sentence is also added in the for loop. For the second for loop we end it with a semicolon. So this is the nested for loop which creates 1 millisecond delay, and we pass on a parameter 1000, so the delay should be 1 second. Let us check it. Now save the file. You can see the led.c file, that asterisk has gone, and then click on build button, that is a F7, to build the hex file. Now the hex file has been created without any errors. You can find it inside the project folder. Before that, let us add another delay after the P0 has been made off. This is very important. So add another delay after that P0 is made 0, and save it. Now click on build or rebuild. You can see the hex file under your project folder. Once the code has been compiled, hex file is created, and if you go to the project folder, under the objects folder, you can see the .hex file created. This is the hex file we are going to upload to the 89S52IC. For that we will be using PROGISP software. Now before that, let us test it with the inbuilt debug. For that, under target, under the debug tab, simulator should be enabled. So click on debug and then start the debug session. Confirmation will ask, as it is we are using evolution KEIL software. Now the debug session has started, and the registers are all displayed to the left, and you can see the variables also. Inside in the center window you can see the code. Now click on run button under the peripheral. Before that, select under peripheral IO ports as port 0. As we are toggling the port 0 pins, select the IO port as P0. Now a separate window will appear displaying the port 0. Now under debug, click on run, that is a F5 button. You can see in the IO port window the bits are blinking, that is the output. Under debug there is also step out functions which is very effective for testing the software step by step. So this debug function of KEIL is very powerful. Now let us test the actual hardware. First we have to connect the port 0 pins to LEDs. So for LED inputs there is a 8-pin strip. We will use a bunch wire like this to connect port 0 to the LED inputs. Initially all LEDs will be high. as it is pulled up. Now open the PROGISP software. No installation is required. Just open the folder and double click on the PROGISP software. The PROGISP software will open. This is the welcome window. Top there is a toolbar, file, command, buffer and about. If you click on about, it will show the version as 1.72. that is the latest version. After that it has not been updated. Under file you can have the functions like load, flash, open project and save. After that command tab is there, and then buffer. And below that some tabs are there: program, buffer, check IO and config. We are not doing any configuration now, just leave it to program tab. First you have to select the chip type. Select it as AT89S52, as we are using 89S52. Select the correct chip, and to the right of that you can see two buttons: program state, that is a PRGISP, and USB ASP. Both should be in color. Suppose you are just pulling out the USB ASP from your PC, then the first one, PRGISP, will go gray. It will gray out. If the driver is not installed for USB ASP, then the second will go gray. So both should be in color. And the tickings you just leave it to default. Verify, and if you want to lock the chip, you can put a tick mark against lock chip, so no others can copy your project. And below that is the erase button and the auto button. Now from under file you can load the flash, or to the right you have the load flash button. Click on that and navigate to your .hex file, that is under the objects under your project folder. Select that hex file. Now the hex file has been loaded to the buffer of PROGISP. Now click on auto. You can see the green bar at the bottom showing the programming process. So it will take some time for programming, and as per the tick marks it will first erase and then program the flash, and then finally verify the flash. And at the bottom window you can see the output, that is the chip has been erased and the flash is programmed and finally verified. And once you get the ready, you can check the hardware. At the hardware, initially that while writing, that red LED will glow on the USB ASP, and then the hex has been loaded to the 89S52. Now the code is working, but delay is more. That is why it is blinking once per 10 seconds. The delay we have created inside the KEIL is not giving correct 1 second delay. Now let us modify the delay from 1000 to 100. Let us give the parameter as 100. Let us pass on the parameter to the delay function as 100, so that the delay function will create 1 second delay. That is 100 into that is actually creating 10 millisecond. That is 100 into 10 millisecond will be 1 second. Save that and then click on rebuild. Now the hex file has been rebuilt. Open the PROGISP. Again select the file load flash and select the hex file we have rebuilt, and then click on auto button. Now the new hex file will be uploaded. Once you see the ready, you can test the hardware. Now the delay is correct and all the LEDs are blinking once per second. Next we will make the LEDs blink alternatively. That is, first LED will be on and the second will be off. Like that, alternate toggling let us do. Go to the code and then change the port P0 as 0xAA. This is the hex notation, and in binary it will be 1010. So first LED will be on, second will be off, third will be on, like that. And after a delay you make that P0 as 0x55. Hex 55 is 0101. So first will be off, second will be on. Now save the file and then click on rebuild. Now the hex file has been rebuilt. Go to PROGISP select file load flash and select the new hex file, .hex file, rebuild file, and click on auto. Now the hex file has been uploaded to 89S52. In the hardware you can see the LEDs are blinking alternatively. The first LED is on, second is off, so it is toggling like that. Next we'll see the single bit function of 8051. So out of this 8 bits we can control the single bit in 8051. For that you have to use the SBIT, and SBIT to be declared globally. The include reg52.h header file defines only the port pins and not single bit. As full port it is defined, and a single bit has to be defined separately, and it should be done globally before the void main. So you see the notation SBIT, and then you provide a name. Let us provide a name as LED equal to P1, and then we use the caret symbol P1 caret 0. So we are going to toggle the P1.0. Note that we are not using P1.0 and we use P1 caret and then 0, and that has to be declared globally before the void main function at the top. So inside the void main function, let us modify P0. Instead of P0, let us use the name LED, which were defined as P1.0. Let us make it as 0 initially, and after a delay let us make it as 1. Now save the file and then click on rebuild. Now the new hex file has been created under the object folder. Open the PROGISP and then click on load flash. Select the new hex file, .hex file, and then click auto. Now the hex file has been uploaded to the 89S52. Now connect P1.0, that is the left hand side top pin, to any one of the LED. At the bottom LED we'll use. Now you can see the LED is blinking as per the code, that is a single bit we are controlling. Thank you for watching.